In this video, we will focus on understanding the concept of velocity time graph. Velocity is defined as rate of change of displacement with respect to time. Velocity is the slope of a displacement time graph. Now, if we are interested in drawing a velocity time graph, then velocity goes on the vertical axis, time goes on the horizontal axis. Unit of velocity is meter per second, unit of time is second. Now let me draw a straight line over here. And let me introduce acceleration. Acceleration is defined as rate of change of velocity, and it is the rate of change of velocity with respect to time. Isn't that the gradient of slope of a straight line? Yes, it is. So if I take 2 points over here and I connect them so that I make a right angle triangle, this is the change in velocity. And this is the change in time. So slope represents rise over run. This is the rise, that is the change in velocity. This is the run, that is the change in time. And that gives us acceleration. So in a velocity time graph, the slope represents the acceleration. What are the units for acceleration? The units for acceleration is meter per second square. In a velocity time graph, we are also interested in finding the area under the graph. For example, if I draw a horizontal line, let me mark this point as capital T. Similarly, this value of V over here is represented by V. Now, if I talk about the area of this rectangle, this area is equal to V multiplying with T. Now, on the vertical axis, we have velocity in meter per second. On the horizontal axis, we have time in seconds. So if I take the unit of velocity, that is meter per second, and multiply it with seconds, what do I get? I get simply meters. That is the unit for displacement. That means another aspect of a velocity time graph is that the area under the graph represents displacement. Now let's draw some common line segments that we see in a velocity time graph.
If you're finding value in this explanation, there's so much more to discover. At Alt Academy, we break down every A-level concept with the same level of clarity. Now, let's continue.
For example, if I make this line a little bit darker, so we have velocity on the vertical axis, we have time on the horizontal axis. This represents that the velocity is 0. In other words, the particle, the object, is at rest, it's stationary, it's not moving. Similarly, if I draw another line on the velocity time graph, and this time the line is parallel to the x-axis, something like this, what does it represent? It represents no change in velocity. The velocity is constant. When there is no change in velocity, that means the acceleration is 0. So always remember that constant velocity means 0 acceleration. Now let's draw a third line segment on the velocity time graph. This time the line has a positive gradient and it's going up like this. What is the meaning of this line? It means that velocity is increasing with respect to time. And the rate of increase of velocity is constant. Why it is constant? Because it's a straight line. And in a straight line, the slope is constant. That means the acceleration is constant. We can also say that the velocity is increasing at a constant rate because the acceleration is constant. So what have we learned in this particular video? We have learned that in a velocity time graph, velocity goes on the vertical axis. The units are meter per second. Time goes on the horizontal axis. We are interested in the slope of the graph as well as area under the graph. The slope of the graph is acceleration. It could have a positive slope, a zero slope, a negative slope. If the slope is positive, we will say the velocity will be increasing. If it has a negative slope, velocity is decreasing. If it has a zero value, a zero slope, that means velocity is constant. And what about the area under the graph? That represents displacement. That is the distance with respect to a starting point. That's what the video is all about.
Now that that's taken care of, head over to our website to watch the rest of our A-Levels maths course. With 60,000 students trusting us, visit All Academy now and transform your A-Levels journey.